So far we've seen that we could transmit a QAM signal and we could demodulate using a cosine wave and a sine wave, and we could find and recover both the original message 1 and message 2. We would be using the same amount of bandwidth as a double sideband suppressed carrier method. So what are the downsides to QAM? So far it seems like everything is great. You can transmit 2 messages at the same time while using the same amount of bandwidth as DSB. So let's consider what the downsides are by thinking about what might happen when we find x1 by demodulating the QAM signal with a cosine wave. So if we were to demodulate using a cosine wave, and for some reason in our demodulation, the cosine wave has a little bit of error, and we add a little bit of extra phase theta to it, we will see that there's going to be some serious problems in recovering our original message. So we are attempting to demodulate. We have some cosine omega CT signal. There's some error that adds a little bit of theta. So now let's see what happens if we try to find x1 when we have this error in our demodulation. So again, just like before, we'll take the QAM signal and we will substitute the QAM signal into x1 of t. Then we will multiply this out and distribute it to arrive here. We have some identities that we can begin to apply since we have cosine terms and some sine cosine terms. So applying these identities, we arrive at a longer expression that has a lot of sines and cosines. And if we multiply some of those through, we'll arrive at the equation at the bottom, and we can see that there are some terms with cosine squared or sine squared. And as you might guess, this is going to be a good situation to apply more identities. So from this expression, we can apply the double angle identities again, which will simplify this a little bit. And if we simplify down to here, we'll arrive at this expression. And we can see that each one of those terms, we can now distribute the cosine theta and the sine theta. And when we distribute those, we will arrive at an expression that looks like this. And again, we can see that there are a number of cosine and sine terms in this, and we can apply some more identities to this, and we can also distribute the message 1 and message 2 through this. When we've distributed the message 1 and message 2 through this, we can see that there are some terms already that contain message 1 of t and just one sine or cosine term. But there are some other terms with message 1 and message 2 that contain multiple cosine terms of both 2 omega ct and theta. So if we arrange this so that the first line has the message terms with the cosine theta and the sine theta, and then the other lines have the message 1 and message 2, we'll arrive at an expression that looks like this. Applying the sum difference identity, we will arrive at this most simplified expression where the first line has message 1 and message 2, and the second line has message 1 being multiplied by a cosine term at 2 omega ct, and the message 2 is multiplied by a sine term at 2 omega ct. So if we were to consider this in the frequency domain, we can see that the message 1 and message 2, those are going to be the lowest frequency components, assuming that the phase theta is small, while the message 1 and message 2 terms that are multiplied by the cosine and sine waves at 2 omega ct plus theta are going to be higher frequency terms. So previously we were able to take the x1 and we were able to pass it through a low pass filter, and we were able to recover message 1 by itself. However, if we look at this x1 where we've demodulated with a cosine wave that had a little bit of theta added to it, We can see that X1 now has message 1 terms and message 2 terms that are at the lowest frequencies. So the part of the X1 in the frequency domain at the lowest frequency contains both message 1 and message 2. So if we were to pass this X1 of F through a low-pass filter, we would recover some kind of signal that contains both message 1 and message 2 that are mixed together. And because they're mixed together, it might be impossible to recover just message 1 by itself. So even if you add just a little bit of a theta, a little bit of a phase error to your demodulation, you might create a situation where it's impossible to recover the message 1 or message 2.